Now we are seeing the expressions for force exerted by jet on an inclined fixed plate. Assume the jet strikes on an inclined fixed plate as shown in the figure. So this is a jet coming out from a nozzle. It is striking an inclined fixed plate like this. And let us take V is the velocity of the jet in x direction. Theta is the angle between the plate and the jet direction. A is the area of the jet and m dot is the mass flow rate of the jet. So this can be written as W by G A V, where small w is the specific weight of the fluid, that is Z. Jet G is the acceleration due to gravity, and we have seen A and V, area and velocity. So let us see how we can write m dot, that is mass flow rate of the jet, as W by G AV. So we know m dot is mass flow rate. So its units is kg per second. So if you see just a simple rough work here. So here it is a W by G, AV is the mass flow rate, and I told small w is the specific weight of this jet. So you can write specific weight as rho into G by G, and AV is there. So G and G you can get cancelled. Remaining things here, rho into A into V. Rho is nothing but density. You can write that density as mass by volume, and for that units are kg per meter cube, area meter square, velocity meter per second. So this is meter cube and these two are meter cube. So this you can cancel these two and this one. So the remaining things here are kg per second. So we know kg per second is a unit for mass flow rate m dot. So we can write m dot as W by G A into V. And see here, here let us write initial velocity of the jet normal to the plate. So if you see, the jet is coming like this and it is hitting the plate, inclined plate. So it is with an angle theta. So just if you indicate with the line diagrams, so this is the inclined plate and is the direction of velocity of the jet, and angle between this plate and jet is theta. So this velocity you can resolve into two perpendicular component. So this component, that is normal to the plate, will become sine component. So that is nothing but V sine theta. So you can write here this normal component of the velocity V sine theta, and so that we are taking this as V1. So that the V1 is nothing but initial velocity of the jet normal to the plate, that is V sine theta. And next, if you see final velocity of the jet normal to the plate, that is 0. So why? Because if you see here, after striking the plate, the jet goes along the plate. So it is going along the plate means, so the final velocity in the perpendicular direction will be 0 because it is going normal to the perpendicular. So since the jet moves perpendicular to the normal, so that velocity of the jet normal to the plate after striking is 0. So here just you can write general formula. We know force exerted by jet on the plate. We know that formula as m dot into V1 minus V2, where V1 is the velocity of the jet before striking and V2 is the velocity of the jet after striking. This is general formula we know. So here we are taking this force exerted by the jet normal to the plate that we are taking. So you can write Fn, and V1, V2 are the initial velocity of the jet normal to the plate, and V2 is the final velocity of the jet normal to the plate. And here we have seen m dot, we can write it as W by G into A into V, and V1 is the initial velocity of the jet normal to the plate, just we have seen it is V sine theta, and V2 is the final velocity of the jet normal to the plate, we have seen it is 0. So when you substitute V1, V sine theta, V2 0, and if you simplify here, it is W by G A V into V sine theta is V square sine theta, and this into 0 is 0, so that we are not writing that here. So finally you can write expression for force exerted by the jet normal to the plate, Fn, as W by G A into V square sine theta. So here this normal force, that is Fn, can be resolved into two components. One in the direction of z, that is fx, and other is the perpendicular to the direction of the z, that is fy. So the force which is normal to the plate, you can write this as Fn. So just if you write a line diagram, if you draw a line diagram here, so this Fn can be resolved into two components, that is along the direction of the z or along the x direction, that is fx, and perpendicular to the z direction, that is fy. So if you see here, this is x direction if you take, and this is the Fn. So this is 90 minus theta. So why? Because if you see this is theta, and if you draw a perpendicular, so that will become 90 minus theta. So otherwise, if you see once again here, if this is theta, and if you see this angle is 90 degrees, means v sine theta, and this plate, so this total is 90 degrees between the v sine theta and this plate, surface of the plate. And if theta goes here, so this is nothing but 90 minus theta, means this axis and v sine theta, the angle between this axis and v sine theta is 90 minus theta from the diagram, we can say. So if this is 90 minus theta, this is also 90 minus theta, because alternate angles. So anyway, you can just draw a simple diagram here, and this is Fn, this is 90 minus theta as it is here, and if this is 90 minus theta, this will become theta. Why? Because once again fx and fy are at 90 degrees. This is, is the basic thing. So if this is 90 minus theta, so this is the remaining angle, that will become theta. So anyway, if you see this Fn, you can resolve into two components, fx and fy, and that fx you can write it as simply it is Fn into cos 90 minus theta, or directly Fn into sin theta also you can write. Anything you can write, and Fy is Fn into cos theta. So if you observe here, Fx we are writing Fn into cos 90 minus theta, that is nothing but cos 90 minus theta is sin theta here, and we have seen Fn as W by G A V square sin theta. So that is in the place of Fn, W by G A V square sin theta, and sin theta is there. So that is sin theta into sin theta sin square theta. So the Fx force, the direction of the x direction is given by W by G A V square sin square theta, and next force in the y direction is nothing but Fn cos theta, we have seen. So if you see here Fy, it is Fn cos theta, you can write. So that we have written here Fy is equals to Fn cos theta, and Fn we have seen W by G A V square sin theta, and cos theta is as it is. So the force in the y direction is given by the equation W by G A V square sin theta cos theta. So these are the expressions of a jet striking on a fixed plate at an angle theta. So these are the force normal to the plate, W by G A V square sin theta, force along x direction W by G A V square sin square theta, force the y direction W by G A V square sin theta cos theta. So friends, for more videos please subscribe and activate bell symbol, and also please share my videos with your friends. Thanks for watching.